let's take a look at number 3 for the limit comparison test. So I have the series n equals 1 to infinity of 2n squared plus 3n over the square root of 5 plus n to the fifth. My b sub n, my biggest term in the numerator is that 2n squared, so I get a 2n squared. And for the denominator, that n to the fifth under the square root is going to be my bigger term. And I'm going to write that as n to the 5 halves. Okay, so my L is going to be my limit as n goes to infinity of 2n squared plus 3n over the square root of 5 plus n to the fifth times, I'll put my 2n squared in the denominator and my n to the 5 halves in the numerator. So my leading term on this piece is that 2n squared, which will cancel with this one. My leading term in the denominator of a sub n is this n to the fifth square root, which will cancel with my n to the 5 halves. So this limit is equal to 1. Okay, so the way that I've designed setting up to figure out b sub n where you include this coefficient almost always gives you a limit equal to 1, but you do want to check that that is what the limit is. Okay, now let's simplify b sub n. So I can factor the 2 out in front, and that leaves me with, let's see, n squared over n to the 5 halves, so 1 over n to the 1 half. And my conclusion statement will be, since L is equal to 1, which is between 0 and infinity, which we need, and 2 times the sum from n equals 1 to infinity of 1 over n to the 1 half. That is a p series. P is equal to 1 half, which is less than or equal to 1, so it diverges. Therefore, the series n equals 1 to infinity of 2n squared plus 3n over root 5 plus n to the fifth diverges by LCT. So there is your write-up. And I'd like you to go ahead and try number 4 on your own. If you printed these notes out earlier, this should be an n to the 7th under that cube root. So if you don't have that, give that a change. And then I'd like you to go ahead and pause the video, give it a whirl, and we'll be right back. Okay, so let's go and take a look at this. We'll see if we came up with the same thing, hopefully. All right, so my b sub n on this one, the biggest term in the numerator is that n, so I'll put an n there. The biggest term in the denominator is this n to the 7th under this cube root. So that is the cube root of n to the 7th. So can we write that as n over n to the 7/3? And let's find our limit. So L is going to be the limit as n goes to infinity of n plus 5 over the cube root of n to the 7th plus n squared times, I'll put an n in the denominator and an n to the 7/3 up in the numerator. So again, this n to the 7th cube root and the n to the 7/3 are my leading terms, so those will cancel to make a 1. Then the n and the n also give me a 1, so my limit is 1. And let's simplify our b sub n. So n over n to the 7/3 is 1 over n to the 4/3. All right, so my conclusion statement is, since L is equal to 1, which is between 0 and infinity, and the sum from n equals 1 to infinity of 1 over n to the 4/3, so that is a p series, and p is equal to 4/3, which is greater than 1, so that converges. Therefore, my original series, n equals 1 to infinity, of n plus 5 over the cube root of n to the 7th plus n squared converges by LCT. All right, so I'm hoping you got there, but if you didn't or you have questions about maybe where you want to stray, let me know. And then let's do number 5. So this is a little different. This one's going to use a geometric series in it. So my b sub n, my numerator will be a 1, since there's not anything else in that numerator, and the biggest term in the denominator is that 2 to the n. So L is going to be the limit as n goes to infinity of 1 over 2 to the n minus 1 times, put a 1 in the denominator and a 2 to the n in the numerator. You said that 2 to the n here and the 2 to the n here, so this limit is going to be a 1. And then let me simplify my b sub n so it looks a little more geometric. I can write that 1 over 2 to the n as 1 half to the n. And my conclusion statement is, since L equals 1, which is between 0 and infinity, and the sum from n equals 1 to infinity of 1/2 to the n. Okay, so I have a number raised to the n that is a geometric series. The absolute value of r is equal to 1/2, which is less than 1, converges. Therefore, my series n equals 1 to infinity of 1 over 2 to the n minus 1 converges by LCT. All right, so there you have an example with a geometric series.